the three capacitors that are in series parallel combination. The 330 microfarad and the 150 microfarad capacitors are in parallel, with the 50 being in series here. Now we do need a value of a voltage source here, so we're going to say 9 volts is attached to all of this, and we've not drawn the rest of the circuit just to keep things clear. The two parallel ones are recorded here, so this is our parallel section in our QVC chart. And we'll get the equivalent right here, and this will be our series part. Okay, and I'll just highlight this just a little bit, or put a little arrow here to suggest that this is our dividing line between parallel and series. Well, the first step is to get the value of our parallel combination, which is just adding them together. Okay, and the value of that would then be 480. Okay, microfarads. And let's just label this as microfarads here. And this, of course, will be volts, and this is microcoulombs. So we need to keep writing the units. Now, basically, then we have a 480 microfarad capacitor in series with a 50. So we can just think of these two then as being the 480. Okay, and then that's just in series with that. So if I want to get the C total for the whole circuit, then I need now to add those as series, and those are reciprocally added. So we'll do 1 over 50 plus 1 over 480. And remember that we do not want 1 over C total. We actually want what C total's value is. And that's 45.3 microfarads there. So I'll write 45.3 right here. Now the entire circuit has 9 volts on it, so I'm going to record my 9 volts here. And then if I want to get the value of our charge for here, I'm just going to use the equation Q equals C times V. So I'm going to multiply my capacitance value and multiply it by 9 here. And the value for that is 408 microcoulombs. And I'm going to write that all the way up to my dividing line here, because in series, the charge is the same everywhere. Now to calculate volts then, I'm going to just use the equation volts is equal to the charge divided by the capacitor value. So I'll take 408 divided by 50, and that's going to be 8.2 volts. And then 408 divided by 480, that will give me a value of 0.85. And these two will add up to be 9. Within rounding differences, we're going to be about 0.05 off, but that'll be close enough. And then when we go across to the parallel, we're going to write 0.85 for the voltages across all of them. For the parallel section, the volts are all going to be the same, but the charges will not be the same. Now to get our value for the charges, I'm going to go back and use Q equals C times V, and they're written right next to each other, C times V equals Q. So I will just multiply those two. I'll get 281 microcoulombs on this capacitor, and the 150 times 0.85 gives me 128. And these two should add up to be about 408, within rounding differences. And that's how you deal with capacitors that are in series parallel combination.